In this video, we will conclude our discussion of colligative properties by looking at gas solubility in solution. And for that, we need to go to something called Henry's Law. Now, Henry's Law states that there is a relationship specifically between the amount of gas that can dissolve, the concentration of gas in a liquid, and the pressure of that gas above the liquid. Um, and that is the overall relationship between gas and concentration. Now, we use this to describe gases in general in terms of their ability to dissolve in liquids. And so, what we can find is that, for something like oxygen, which has a relatively low solubility in water, we find that if it is in a higher pressure situation, um, then it's going to have a greater concentration inside of the water. And if it is in a lower pressure situation, or if it's in an area that is depleted of oxygen in some kind of way, like in a marsh, then we're going to see a lower concentration of oxygen inside the water, and ultimately that's going to lead to the overall changing of the ecosystem in that marsh. It's one of the reasons why in certain areas we don't see a whole lot of plant and animal growth, especially animal growth inside of certain types of brackish waters or standing water areas where there isn't a whole lot of oxygen being exchanged. And so, therefore, there isn't a whole lot of oxygen that is dissolved in the water to support things living in there. Now, the other thing that we can point to as being pretty important off of this is there is also a relationship between the temperature of a liquid and how soluble gases are in that liquid. When we see higher temperatures, that also comes with a decrease in solubility. When we see lower temperatures, that usually is associated with an increase in solubility. And so I tell you all of this stuff not because I'm going to require you to do a whole lot of calculations. In fact, that's one of the reasons why I haven't given you the value of Henry's Law here. I'm not going to ask you to use it. I'm not going to ask you to actually calculate how much gas can dissolve. I want you to understand the concept, though, because the concept is important. I already mentioned a couple of biological examples of where this has particularly direct impacts. There's probably an even more familiar example that you can think of. And it's right here in this bottle. In this bottle, you have a perfect example of Henry's Law. Henry's Law tells us that when the pressure is great, the solubility of gas is great. And tells us that when the liquid is cold, the solubility of the gas is more pronounced as well. So when you think about it, you have a bottle of a soft drink like what's shown on the screen here. And when you first open it, what's the first thing that you see? Well, the first thing you see is that all the bubbles that were in here start rising to the top. Why does that happen? Well, consider how it was bottled. It was bottled under higher pressure, so there was a higher concentration, a higher pressure of carbon dioxide that was on top of the liquid here, and that was causing all of those bubbles to stay in the liquid. And now when you open that and release that pressure, the first thing that happens is the pressure above the pressure inside of that neck there is now atmospheric pressure, far less than the pressure that it was when it was bottled. And as a result, less carbon dioxide is immediately brought out of solution. It starts to bubble up to the top. So when is a bottle of soda the fizziest? Well, obviously when it's first opened. After a week or so, after a couple of days, we see a significant decrease in fizziness because, well, the pressure has normalized and the carbon dioxide that was dissolved in the liquid is no longer dissolved in the liquid. In the same way, we can look at soda or any beverage like this in the same kind of way. When it is cold, it tends to stay crisp and refreshing longer. If you leave it out all day, it's pretty flat by the time you get back to it. If you open it up when it's warm, it goes flat much faster. So when it comes to Henry's law, this is the way I really want to think about it in terms of solubility. The easiest way to do it is there are two principles. Gases dissolve better when the liquid is cold, and gases dissolve better when the pressure above the liquid is high. And so that's all that we really need to look at for Henry's law. And that concludes for us our look at colligative properties in chapter 11. Have a good day.